We propose to use deep learning to restore old photos in this paper. This is a joint work by City University of Hong Kong, Microsoft, and USTC. People are nostalgic and always memorize their old times. Each of us may have taken photos a long time ago, and sometimes we wish to bring these moments back to life. However, existing photo restoration is rather expensive and time-consuming. Most of users cannot afford these online services, so can we use deep learning to automate this process? By analyzing the existing old photos, we could conclude that the defects of old photos mainly comes from two aspects: the real unstructured distortion, such as blurring, color fading, some slight blur, and the structured distortion, such as scratches and dust. Our target here is to solve them together with only one network. We firstly introduce some previous work on mixed degradation restoration. Basically, we want to restore one corrupted image from its static degraded version. The noise, blur, and JPEG compression of different levels will be injected into one natural image to construct the pair data. Then the training will be processed by the synthetic pairs. There are mainly two drawbacks. Firstly, their trained models may not generalize to real photo well. Secondly, they only focus on the local degradation and don't handle the global defects, such as restoring the broken region. Ideally, we can train a network on synthetic datasets. However, the real degradation can be rather complicated, and there is always a gap between the synthetic images and real photos. So the learned network may not generalize well on real ones. To solve the domain gap, we propose a triplet domain image translation framework. The idea is that we project the two image domains into a latent space. This latent space assumes a Gaussian prior and has a compact structure, so it is easier to close the gap in this space. Then we learn the decoder which maps the latent space to clean images. The decoder can be learned using the synthetic training pairs. Because the domain gap has been reduced, the same decoder can also work well for real photos. This slide shows the network structure. Basically, there's two VAEs. The first VAE equals the old photos and the synthetic image to a shared latent space. And the second VAE obtains the latent code of clean images. Since the synthetic and clean images are pair data, then we can learn the mapping between them, their latent space. This means no matter what kind of degradation exists in the input image, we want to obtain one clean and complete image finally. We also design models for this latent mapping network so that it can achieve multiple tasks, such as denoising, color correction, image imprinting, and so on. And the residual block of domain translation network mainly focuses on the local defects and cannot capture the long-term dependencies relationship. We design another partial non-local block to assist the implementing task. Specifically, given one intermediate feature map of latent translation network and the corresponding dorsal mask, we calculate the normalized similarity between the whole region pixels and non-whole region pixels through the embedded Gaussian function. Based on the global context feature, we could generate one new feature map. Combining original local features and new generated features, we fuse them together according to the mask. Our method is compared with previous works. The table shows that on synthetic datasets, our method is always among the top in terms of various metrics. So the advantage of unreal photo is more obvious. Our method gives much more compelling results. Here give more results. We also test on portraits of celebrities. After restoration, these photos could look like the photographs taken by modern cameras. And you could find more details in this website. Feel free to contact me if there are any questions. That's all.